I will be talking about Presto, which is fast SQL engine that can run on basically any data. I'm curious who already is using Presto or heard about Presto in the audience. Okay, I see some hands. Good, good. All right. Okay, cool. So the short history of Presto is it's about 6 years old, open source project, first developed by Facebook for their internal usage to basically make queries fast again, right? Because after moving to big HDFS and dealing with petabytes of data, all those queries became really slow, and Hive wasn't able to run interactively at that time. So they built a new engine from scratch completely. So my team is actually part of the Presto community for over 3 years by now, and we contributed a bunch of features. I will talk about them later. But in a nutshell, Presto is essentially a great SQL engine. It's not a data warehouse. It doesn't own your data. You keep your data in your own favorite format, whether that's cloud storage or HDFS or any kind of storage. And you can actually see a long list of connectors that Presto ships with today that you can connect to from Presto, right? So you can issue SQL statements and refer to your data, your tables defined, either HDFS or S3 or blob storage or MySQL or Cassandra and a bunch of others, right? And this list of connectors to different data sources for Presto grows basically every month because lots of companies using this software and they're contributing connectors to the platforms that they want to query. Not only you can query individual platforms itself, you can actually drive queries that are joining tables from multiple data sources at once, right? Which makes it pretty amazing tool for sort of virtualizing data access, right? And then because it's a SQL engine and the team is actually aiming to provide full ANSI SOL compatibility, you can actually use a bunch of BI tools and SQL development tools, notebooks, and all sorts of different tools to access Presto itself. You can still obviously write your queries by hand if you prefer and put them on a command line, right? But most of your users will be more comfortable with those BI tools. Okay, so you might be curious, like, who are Presto users? There's actually a lot of them already, and the giant user is obviously Facebook because they developed this in the first place, and they invest a lot in the project still and sort of run thousands of nodes. But there's a long list of other companies, so from financial to media, telco, all over the place, big and small companies. And if you are already using Presto but you are not on this list, let me know and I will fix it. If you are not on this list and you are not yet using Presto, let me know, we can fix it too, right? Okay, so some of the biggest users that have Presto in production are, yes, Facebook, but also Uber, Twitter, Lyft, LinkedIn, Netflix. So all the big guys are using this technology already at massive scale, right? So you can run clusters, hundreds of nodes, each Presto scales and it's reliable and a highly concurrent SQL access. And Presto is pretty unique because it can run like both cloud, on-premises, can run in a virtualized environment. So it's very, very flexible how you want to apply it. That's why it's popular among all those different applications, right? It doesn't try to shovel you into like one way to do things, right? So you can roll your own infrastructure if you want. So for example, Netflix was originally using this in the cloud, using sort of standard EC2 instances. Last year, they started migrating this to a container-based environment, and they're not using Kubernetes. It's something they develop in-house, but it's basically sort of flexible container infrastructure, so you can scale the number of containers whenever your workload increases for a particular application. Cool. So a quick overview of Presto architecture. to enable this parallelism and scale, obviously it's running on multiple nodes. And as I mentioned, it's very flexible how you want to deploy it. But essentially, in sort of logical architecture, you have one coordinator, which is really a brain of the system, and multiple workers that actual query processing. So the coordinator will accept a SQL statement from the client, and then do a sort of standard parsing, analyzing, and planning the query execution. And then scheduler will take care of sort of orchestrating the actual parallel execution of that query across the workers. The workers themselves, basically, they kind of read the data from the storage and then basically apply all the processing like projections, selections, aggregation, joins, and they kind of all collaborate to compute the query. And query, obviously, in this example doesn't show that, but the query may be obviously multiple stages, lots of different operations, but at the end, there's a final result that's returned to the client. What's pretty unique in Presto versus other SQL engines is that it's actually pretty pluggable. That whole storage layer that I was showing at the bottom on the first slide is essentially a pluggable thing, which means you are not tied to any specific data source. There's actually API to develop connectors to all your storage engines. So in this picture, I'm showing 3 different pieces of that API. So there's metadata API, which allows Presto to understand what are the tables and schema and columns and data types that are exposed by your data source to Presto. So Presto will understand the sort of the relational mapping from your actual data source to sort of SQL standard objects. And then there is data location API that essentially allows Presto to understand how to parallelize the execution of the query, right? If your data source is just a single node MySQL database, it will be essentially like a single threaded access, right? But if you're say sharded MySQL, then that data location API, you can implement that the way that exposes that parallelism to Presto so that multiple Presto workers can read data in parallel from your storage and achieve great speed up. And then actual workers have data stream API, which is essentially, okay, I got this data parallel unit. What do I do with it? I got the split, right? So I just need to understand how I sort of transform the stream of bytes that's coming from the data source, and how do I translate this into rows and columns that I'm actually going to process, right? And then the rest of the execution, right, engine is completely agnostic to what's your data source, right? There are no specific optimizations for this or that format. Everything is sort of contained in that connector API, right? So that's basically pretty powerful engine because pretty powerful architecture, because now you can completely replace your storage engine and move from one to the other. For example, say you have HDFS on premises, you decide to move to the cloud, right? Your users are completely unaffected, right? Like the SQL users, they see the same set of tables, the same set of schemas, right? And the queries will not change. You just sort of move the data and map them map that data properly to tables. So I think that's that on the architecture. There's obviously lots of details that I can dive into during the office hours. But like I was sort of I'm trying to motivate why people would use Presto, and if it's not obvious already, well, Presto has this advantage because it's actually a community-driven open source project. Unlike many of the SQL engines, especially from the Hadoop ecosystem, if you're coming from that environment, like each open source project was essentially driven by one of the vendors, right? So if you happen to use, say, distribution A of Hadoop, then you'll be stuck with Hive. If you're using B, maybe you have Impala, right? And maybe sometimes you get Spark SQL, but maybe it's an older version of Spark SQL that ships with that distribution. So it's pretty much you're sort of under you're under their influence and control, what you can use on your platform. With Presto, it's pretty amazing because because of those giant users of Presto, they are driving sort of the development in the project, and the community moves essentially based on the needs of those big users. And then if you need help, and if you can go to the mailing list, you can roll this yourself, right? Or you can also ask Presto experts for help. So that's that. It's pretty amazing open source project. Lots of different initiatives were built on top of Presto. So you might be familiar with Amazon Athena. It was basically they took Presto and they built a service on top of that, right? So it's basically I think another validation of Presto being amazing SQL engine for the cloud and those flexible deployments. Another big thing about Presto is its high-performance SQL engine. Thanks to sort of recent advancements of Cost-Based Optimizer, proven scalability of up to 1,000 nodes, and high concurrence use cases that are run by those big companies, is basically when you enter a Presto ecosystem, you can have this confidence, right, that I'm not going to hit like some bugs that were not yet exposed in terms of scale, performance, concurrency, right? Because all those big guys already found those bugs and fixed them, right? So I think that helps a lot in adoption and speaks to the maturity of the project as well. And then a major sort of fundamental thing, which I touched upon already, is the separation of compute and storage, right? If you were entering Hadoop ecosystem, say 8-10 years ago, basically when I started, right, looking into Hadoop and big data, like there was this mantra, yeah, bring compute to your storage, right? Like tie them together, right? Because shipping data is so expensive, right? And it's very costly, right? You need to bring everything into your Hadoop cluster. Everything needs to run inside, right? That's no longer true, right? All the modern architectures right now separate storage from compute, allow those two layers to scale independently, allow you to grow your data without limit, and also scale up and down your compute whenever you're ready to pay for additional compute, right? And allow you to save cost of compute when you're not using your cluster, right? Or you're running fewer queries because of the holiday season, for example, right? And the fact that Presto can access all the different data sources is also modernizing your architectures in a sense that you are not necessarily required to bring all the data into one place, into this one central data warehouse that needs to go through all the ETL process, and basically before you can hit the insights, you have to wait a long time, right? So you can bring some insights earlier when the data is still fresh in your data source where it was first arriving, right? So for example, you can talk to your Cassandra and get some latest updates from there. You can go to Kafka and fetch the latest events from your Kafka, right? And combine that with the historical data. So before sort of that data is properly transformed into the optimal long-term storage format. So that's basically it. And then I mentioned this sort of, it's community-driven, there's no vendor lock-in. And what I mean by this is you're not tied to any Hadoop vendor anymore. You're not tied to any cloud vendor, right? Because you can actually deploy Presto in any of the public clouds. You can run it in your private cloud. If that's the strategy your company pursuing, you can basically do it anywhere you want. And then you are not tied to a specific storage engine, right? So if, for example, S3 becomes obsolete in 10 years, right, which seems crazy right now, but like say that it happens, right? There will be essentially some development in Presto to develop a new connector for the new data platform, and you will be still using Presto on top of that, right? Which is pretty amazing to sort of separate that responsibilities. So I talked about how Presto is a great ANSI SQL engine, which essentially means it can basically run most of the SQL statements you can imagine, right? You can take complex workloads from, say, Redshift or whatever is your favorite MPP SQL engine today, and run them on Presto pretty much without much changes. But Presto also spans beyond ANSI SQL by offering a huge, long list of various functions, extensions. So some of the common use cases that we see are people using this for sort of parsing your textual data, log data, using regular expression functions that are there's a huge list of those available in Presto already. There are Lambda functions and expressions built into SQL, so that basically, again, is an extension to Presto itself and to ANSI SQL standard, but allows you to sort of have more expressive and sort of more concise expression of your SQL transformations. And also geospatial functions, big new feature. Not too many people know about this yet, but over a year ago, actually guys from Uber developed pretty neat extensions to Presto to allow geospatial analytics through SQL. And now they published this, they contributed back to the community, and now Facebook also picked this up, and they are putting lots of effort to optimize execution of those queries, especially if you're dealing sort of with very large data and you're joining on geospatial conditions rather than standard equi-join conditions. And I'm listing some examples here on the right, so you can take a quick look how you may structure those kind of computations in Presto, right? And it's pretty amazing that you can do complex analytics like that in your SQL using some extensions to it. And then sort of to complement your standard ANSI SQL data types, you can also use JSON, arrays, maps, and complex structs to sort of process more of sort of semi-structured data inside Presto as well. Cool. So I mentioned up front that there's a bunch of tools that can work with Presto. Because Presto is open source, naturally some users expect various open source tools to work as a clients, right? So some of the popular tools we see is Redash, Superset, which is actually coming from Airbnb, and Jupyter Notebook as well. So those are sort of gaining popularity now. But because Presto ships with JDBC and ODBC drivers, you can connect to virtually any tool that sort of will be working with your standard BI and SQL environments. So if you have Tableau or things like this, they would continue to work. SQL Developer even, right? So whatever works for you. And then people are embedding Presto inside their applications, right? So there are lots of bindings like C, Go, Java, Node, Python, and so on. So you can actually call out to Presto from all those different languages using sort of the standard methods available in those languages. And then in terms of extending Presto, right, you may have a favorite UDF function or UDAF, right, which is like, okay, I want to make sure that this runs inside Presto, right? So Presto has those APIs. You can develop those functions, follow examples from our documentation, and essentially deploy a jar with those functions into Presto, and you can use that SQL, new SQL function you develop inside your SQL statements easily. And then there's the whole connector SPI, which allows you to develop connectors for data sources that are not yet supported out of the box, or you might be touching your internal systems that are not sort of public interfaces, and nobody is able to develop those connectors. So we see people developing connectors to their internal platforms that expose REST API, right? And because those platforms may serve data, and this data is not available through other means, they may develop a simple connector to basically reach out to those platforms and sort of represent this data from the REST calls as tables and columns, and Presto then can run SQL on top of that. Okay. So to make things easy and you know, to sort of tie this back to like what we do, right? So we contribute a lot to Presto itself, to the core, but also we sort of try to make it more easy to use for our customers. So we do sort of have our own offering of Presto on AWS marketplace, and it's fully integrated with Amazon services. So like Amazon S3, Google Catalog. It ties into auto-scaling available in AWS, which means that you can actually start using Presto as a small cluster of 5-10 nodes, right? Pay as you go, and then if your needs grow, you can sort of auto-scale this to a larger number of instances, pay for that spike, and then shrink back when you are not using Presto that heavily, whether that's you know, night hours, weekend, or holidays, or something like this. And then if you reach sort of a certain scale, you're really big users, as some of our customers, you can sort of get an enterprise license from us and sort of have custom pricing as well. And follow the links if you want to learn details. So we recently also entered Azure HD Insight, so you can use Presto as an application on top of Azure HD Insight, which is their Hadoop platform equivalent of EMR on AWS. And on that platform, you'll be talking to blob storage, data lake storage, Hive Metastore that ships with HD Insight, and Power BI, and all that sort of Microsoft ecosystem. And it's also great if your company is pursuing sort of hybrid cloud or multi-cloud strategy. Presto is a great bridge, right? Because it can serve your use cases on premises, but also AWS and now Azure, right? So you can sort of use the same interface for your users across all those environments, and they don't need to learn new syntax, new language, new tools to interact with SQL and their data. Okay, so you might be curious, like, what makes Presto fast and appealing, right? So some of the sort of internal considerations that were part of sort of the initial design of Presto when Facebook engineers started developing this, like those 4 guys who really started working on this project 2012, they basically took sort of the best chapters from the classic database architecture and MPP SQL engine. They took all those best chapters, best practices, and developed Presto according to those sort of state-of-the-art MPP engines, right? So in many ways, what the execution of Presto is very similar to what you can find in sort of parallel database engines, and you know, I would name things like, say, Netezza, Vertica, Greenplum, other Redshift to some extent, right? So some of those considerations on the execution engine are very similar, which makes Presto uniquely positioned to challenge those proprietary old-school data warehouse solutions, because it's actually following the same implementation sort of design details. So it's MPP engine, right? But unlike things like Hive or Spark that are optimized for fault tolerance, long-running jobs, environments that can break at any time, Presto makes a trade-off of optimizing everything for performance, which means the data, intermediate data between various operators and stages is pipelined across those workers in memory, right, and over the network, right? So there's no like checkpointing, making up sort of a fallback mechanism, right? It's basically pipelining intermediate results as soon as possible and try to get to the answer as quickly as possible, right? And that basically means it can achieve great latency at the expense of fault tolerance, right? And that's basically because Presto was developed to be this low latency, high performance, high concurrency system, right? So you don't expect queries in Presto to run hours. And the likelihood of failure is pretty small if you're running seconds worth of execution, right? So it's easier to sort of restart the query and basically come up with the answer again, rather than to try to fall back to some partial result, because it's not really worth to redo it's worth to redo the old computation and arrive at that result faster than just basically do this step by step and retrace your thing. So that's makes Presto complementary to some of the technologies such as Spark and Hive, because those guys are optimized for long-running jobs, data pipelines, ETL, but they are not optimized for low latency, high concurrency workloads that Presto is good at, right? So those are the sort of the design considerations. Anyway, so to sort of dive into performance, right? Presto is optimized for columnar vectorized processing. So internally, its data is represented as the columns and vectors. The moment it gets out of the storage, it's transformed into this internal representation that's very efficient. It compiles the bytecode, so it compiles your query into a bytecode to sort of save your CPU cycles. Has sort of custom memory-efficient data structures internally to again make fewer runs of GC, right, and things like this. And multi-threaded, multi-core execution sort of is trying to get as much as CPU power out of your machines as possible. Optimized for the columnar formats. So if you already store data in your columnar formats, such as ORC, Parquet, whether that's Hadoop or S3, Presto will be having really optimal path from those column storage on disk to internal in-memory representation that's also columnar. And then recently we introduced a Cost-Based Optimizer to Presto, which allows us to execute very complex queries, much more efficient, faster, but also use fewer resources and basically approach those speeds of the commercial SQL engines. To just quickly recap what CBO is, there's a whole presentation I gave at the DataWorks Summit earlier this year, but we basically leverage statistics. Initial version includes statistics from the Hive metastore that most of you already have, right, and store your stats there. We leverage that to do join reordering. So if you have 5 joins, we try to predict which ones we should do first to save you on memory and CPU and arrive at better performance at the end. And then we do things like decide automatically which join type we should use, so you don't have to hint Presto whether it's using a partition join or broadcast. We can make this decision automatically, and we can also pick left and right side of join automatically for you, again, to save your CPU and memory. And we have a whole series of blog posts on the internal design and implementation of Cost-Based Optimizer in Presto on our blog. And then just to give you sort of a teaser of the results, right? So if you compare Presto without CBO and then so for our early release with CBO, which was released back in end of March, those are sort of some of the speedups you can achieve, right? So we take a very complex workload defined in the TPC-DS benchmark, which is essentially a retail kind of workload with like 20 plus tables and so on. And you see the more complex queries, we are achieving higher speedouts because now we can predict execution and what's the optimal plan to execute those queries. And that means your queries will be faster, so your users will be happy, all right? You'll be using fewer resources, which allows you to run more queries concurrently and reduce maybe your expenses on the actual hardware growth because you are just smarter how you execute your workload. And while you can do lots of tuning manually, like at some point, at certain scale, it's just impossible to predict all the user queries, right? So you want CBO to solve those problems in majority of times so that you don't have to do this manually. And actually our friends from Facebook, when they pick up our work on CBO and they run this on their production workloads, they were very impressed because CBO was smart enough to basically never regress versus the highly tuned, manually tuned queries that they had in production, and also uncover some potential speedups that we were not able to achieve by hand because nobody thought about this particular execution path. So it's actually proving to be very efficient even for the smart engineers at Facebook. And if you're running in the cloud, right, so what does it mean, right? Well, you can run your workload on fewer machines, right? Which means you're paying less, right, for Amazon infrastructure. So that's great. You can run this faster. You can also execute more queries within your constraints on your cluster. Say you have 10, 20 nodes. You don't want to expand your cluster infinitely. You can run more queries without failures, right? Because you are not exceeding memory allocations that are available to your cluster. And that basically means you can either run a smaller cluster, pay less, or do more work, more queries at the same cluster, right, at the same cost, right? So that's pretty amazing. And so when we run the same workload on the Amazon infrastructure, we sort of saw, over 60% of queries, almost 2/3 actually, are 5 times X or faster, right, than the baseline Presto from EMR that you can get from Amazon, right? So it's pretty amazing, and we haven't seen any regressions too. So very good results. Full detailed disclosure of this benchmark is under this URL if you're curious. And then, you don't have to take our word for this. Obviously, we contributed a lot to this effort, right? But there are independent studies right now on the web from Fivetran, Concurrency Labs, and a few other users of Presto. And they basically compare Presto versus Spark, Presto versus Redshift, Presto versus Snowflake, BigQuery, all those other technologies. And you can see how Presto fares against those, right? And not to spoil the surprise, but it basically Presto sort of is in the same ballpark in terms of performance and at very, very good cost benefit as well. So you may want to check this out if you're already unhappy with your bills on other SQL engines. Okay, cool. So just finish off, right? Like, if you are not using Presto and you want help from us, we are sort of one company that sort of helps to get you more out of Presto. So we are sort of about a year old, but we actually were part of Presto community for over 3 years, and we are contributing a lot to this open source project. So you can see contributions from our team on GitHub. We have our own distribution of Presto for on-premises and cloud environments, which is basically pre-packaged, easier to use, stable, tested. You can kind of think of us as, like Cloudera was for Hadoop, right? Or Hortonworks was for Hadoop. Like, we kind of provide that kind of level of service to the community. And we support customers in production 24/7, right? So if you want to roll this in production and you don't want to own it all the time, and you want someone to call and fix the bug or triage the performance issues you see, right? Like, we can help with those things. And we have some subscription add-ons for enterprise users too. If you are curious, I can discuss details and can check us out at the table as well. And some of those major things that we contributed to the open source to everyone's benefit is extensions to ANSI SQL to make it fully compliant, various performance improvements to execution, security integrations as well, like Kerberos LDAP integrations, spill to disk, right? So if you're running out of memory on your cluster, you may want to sort of have ability to spill to disk locally rather than fail a query, right? So that's another thing we contributed. And then Cost-Based Optimizer was basically a major effort that my team was pursuing for over a year, and we sort of shipped that in March and contributed back to the community as well. Okay, cool. So that's all. We have a table outside if you want to grab a T-shirt or candy and things like this, stickers. You can follow news on Presto, on Twitter, blog, and newsletter. And obviously I'm hosting office hours as well. If you want to dive into details, you're already running Presto, you have some challenges, you'd like to share your experiences, always happy to help any community members and learn more about Presto users. Thank you so much.
So can you use Presto for like unstructured data, and can you use it like against NoSQL data stores? That's one. And how does Presto compare to something like Dremio? That's two.
Yeah, great question. So let me scroll back here. So some of the, I guess, NoSQL engines that we support today would be it's Redis, Accumulo, Cassandra, Kafka, MongoDB. Those are currently supported. We are hearing about HBase a little bit, although less than in the past. But that's another connector that might be supported at one day. Yeah.
Does the schema need to be defined?
Do you need to predefine the schema?
So some of those engines expose SQL-like schemas. So for instance, Cassandra, you can query, and they will give you a list of tables and list of columns and things like this. So some of those do. Some of them, like say Mongo, you have to, I think you have to apply some mapping, and I think that also applies to Kafka. You have to provide some mapping in your configuration. So your connector is like this glue that's sort of between your data source and Presto. So that connector code typically comes with some configuration, and you can plug in different things there to allow us to understand better how to map this sort of the inherent data source schema to sort of more like database schema that Presto can understand. Yeah, so it depends on the connector exactly. It's all documented online if you'd like to check this out. But yeah.
Yeah. How do you?
Oh yeah, the second question about the Dremio. Dremio is one of those examples of SQL-on-Hadoop that was developed by a vendor called MapR, if I recall correctly, right? It's shipping with MapR distribution of Presto. It's Apache project, right? It's SQL. I guess when people ask me to compare this, like I think Dremio has this very neat angle of like discovering your schema at runtime. Like so, you don't even have to define it, which is pretty amazing feature. Other than that, I'm personally not aware of like big community users of Dremio that will sort of show me numbers like those. Which I think their adoption is probably limited to the MapR user base, and that's why they're not really publicly speaking about this.
I have a question about how you see customers use Presto. At least when I first became acquainted with it, it seemed like more of an OLAP query engine, but it certainly makes it easy to run batch-style ETL because of the connectors. It's kind of a debate we always have internally, and I'm curious what you see more people out there using it for.
Right, so I mentioned earlier in my talk that Presto by design was optimized for those shorter, faster queries at concurrency, right? So that was true originally, and it's still true because Presto doesn't have fault tolerance built in, right? However, when you talk to some of those Presto users, some of them use Presto for both ETL and sort of low latency BI kind of workloads. Even internally at Facebook, they migrated off a bunch of pipelines from Hive, which was obviously fault tolerant, but super slow at scale, right? So they migrated to Presto. They did some sort of engineering to break those long queries into a series of smaller queries so that they can actually like manually checkpoint, write the intermediate output to like disk, HDFS, for example, right? And that way they can enable some replay logic, but because of the benefits of Presto speed, they can actually basically save 80% of the cost of running that pipeline, which is a good trade-off regardless. So we do see people playing with this idea and doing this. It's still not like a common practice. Common practice is still use Spark or Hive, but I think it's getting some popularity. And if you do it sort of in a sort of reasonable, smart way, I think it can help you there as well.
Thanks.
One thing that Presto promises is, its ability to do federated queries. Right, it's Presto connects with multiple databases. So let's say I have two or three databases like MySQL, Oracle, and Teradata as well. Right, I get connected to all of them, and I have a query that needs to get data from all these three data sources. Can this be done in a single query? How often do you see that in real world? This kind of multi-database based requirements.
Yes. So definitely Presto can be used to federate queries or virtualized data access So because in your Presto system, right, you can actually define multiple catalogs and mount Presto, like you have Presto cluster and then you say, okay, this is my HDFS cluster, this is how you access this is my S3 compatible object store, this is my Cassandra, and you can actually run queries across them. So which means you can refer to tables from different data sources that are mounted to the same Presto cluster. And I think maybe I skipped that detail, right? But Presto will actually push down processing to the underlying data source for things like predicates and column selection. So it will only fetch the actual data that it needs for the particular query rather than bring entire data into Presto, right? So it's very efficient. And yes, you can run queries that are sort of correlating data between different systems, and that's a pretty common use case too. Okay.
Any last questions? One back here.
Hi. So my company's been using Amazon's Athena, which you mentioned before, sort of a managed version of Presto. Honestly, sometimes banging our heads on the wall with it because it seems to be claiming to be serverless, but actually having limits, looking much more like a traditional server. So can you contrast sort of like your approach here is you do have to sort of provision capacity ahead of time. How do you compare your approach and overall performance with Athena? I see a lot of comparisons you have on your blog with Presto on EMR, but not necessarily with Athena.
Yep. Yeah, great question. So I would say yes. So Athena was built using Presto code, right? It's exposing Presto or query interface, and they basically picked a different business model, right? They charge you per query, right? Not per cluster, running cluster like normally on EC2, but per query, and they look at how much data you read, and that's the basis for billing you, right? Honestly, yeah, it's obviously you can compete between these two approaches, right? Running the fixed cluster or auto-scale cluster that you pay for compute or be charged per query. What we see Athena to be really popular for is infrequent queries that are unpredictable. You just once in a while want to run a big query. You don't want to spin up a cluster, manage the whole infrastructure, right? Yes, it has those limits, and we heard that feedback from our customers too. That some queries fail and so on and so on. You cannot actually expand capacity. It's a black box. It's a SQL interface. That's it, right? So it has those challenges. In terms of performance, right? So you have to guess like what's behind Athena, right? Like some people say it's 10 nodes, 20 nodes, whatever, right? So yes, there will be limits to how big queries you can run in Athena. No limits if you provision your own Presto cluster, right? Because you can scale it to 100 nodes, whatever, right? So no limits there. If you're running consistent workload, lots of queries concurrently, you probably want to own the infrastructure because you're not built per query, right? You just build fixed amount or more or less fixed amount for your compute time, right? So for real production use cases, we definitely recommend getting your own cluster. You can also tune it for your workload, which you cannot tune Athena because, again, it's a black box, right? So those will be the considerations, right? Yeah.